In problem 6, we have a mass moving along, we know its velocity, and the question is, if we have a force that brings it to a stop in 17 seconds, how large does that force need to be? What does the magnitude of that force need to be? Well, what are the pieces we know? We know the mass. Right? The mass is 36.6 kilograms. We know the velocity, the initial velocity it's at is 4.19 meters per second. All right, so we know those things. We know the final velocity. What's the final velocity? That's 0 because it comes to a stop. We know how long this takes, 17.1 seconds. And so those are our knowns. Those are the corners to the puzzle that we're after. And so we got to pick an edge. And you really want to try and pick an edge that involves all the corners. So we could do this through kinematics with conservation of energy. And so we could do that piece and figure out the acceleration it takes to stop in this amount of time. We could. But that involves more than just one step. I'm going to go at this through the impulse equation, right? So impulse is a force gives you a change in momentum for when it's applied over some time. F is delta P over delta T. So why do I go with this? Well, what's our initial momentum? And what's our final momentum? 0. So I know the initial momentum. I know the final momentum. So that's good. I know the time. And so I've got everything here that I need. And this is actually going to work out to be negative, which is, it should, right? Because the force is trying to stop the motion. So the force is in the opposite direction of the motion. So your final momentum minus your initial momentum divided by how long it takes for all of this to happen. Now, this is going to be negative as it should be. But what do I ask for in the problem? I ask for the magnitude. The magnitude, you're just going to take the absolute value. And so the magnitude is going to be positive. It's going to be mvi over delta t. And that gets you to the solution in problem 6.